Welcome back. In this Microsoft Azure Architect series, we'll discuss about how to choose disk storage. Okay, disk storage has come across multiple different technologies, like starting with floppy drive to compact disk to hard disk drives to SSD, and even there are a lot of new technologies that is coming up or evolving. But Microsoft Azure provides you two major categories of disk storages. One is your hard disk drive, HDD, and the other one is the solid state drive, SSD. The hard disk drive, as you know, it is having the plater and the spindle, and it provides you moderate IOPS or input output per second plus throughput. Because the technology is outdated, maybe you will not get the same amount of throughput and amount of IOPS that you get in your flash drives, the SSD drives. So we'll get into a little more details around why Azure Disk Storage first, and then we can move on to understand what are the different disk drive categories that Azure offers. So whenever we go and choose a storage drive or a disk storage, we generally look at the capacity that it offers, right? So capacity is definitely the first one, and then we'll also look at the performance that we get from the disk storage, like what is the IOPS throughput and what is the bandwidth we are going to get from that particular disk storage. So Microsoft Azure, it provides you a disk category called Ultra Disk, which provides you up to 1,60,000 IOPS, and you also get 2 Gbps disk throughput per VM. Okay, this is the best-in-class high IO performance VM that you get in Microsoft Azure, and not just that, right? So you also get the unmatched resiliency here. So there is this is the you are getting in enterprise grade durability, and they are providing you 3 replicas, and that provides you 0% annual failure rate. So the AFR is 0%. This is the industry leading guaranteed uptime, or the AFR value that you can get. So the durability is very, very high, and also the cost aspect, it is very cost effective disk storage. You can run clustered application or highly available application, but definitely it is cost effective, and they also provide you shared disk, which can be shared across multiple availability zone, or in cloud terms, multiple data centers. You can share that particular disk actually. So there is a seamless scalability as well. You can go and scale it without any performance disruption. You can go and meet the demand by expanding the premium SSDs or the ultra SSDs by expanding it online, and it provides you seamless scalability. Here we have availability also. You get 99.9 with single instance, and if you go for multiple instances, you get maximum availability also, and you get a lot of flexibility to meet out any kind of spiky workloads or seasonal workload. So you also have granular control to go and change the IOPS, the throughput, the bandwidth, the capacity without impacting the other parameters. And definitely there is built-in security. Azure secures your data with automatic encryption using Microsoft managed keys, or you can bring your own keys to cloud. So capacity, performance, durability, availability, scalability, flexibility, and security, they provide you top in class or best in class benefits. So definitely Azure Disk Storage is the way to go for your virtual machine workloads. So whenever we go and create a virtual machine in Microsoft Azure, you might have to create multiple disks for your operating system, data drive, applications, databases, and even for caching and page file, you might have to have separate disk drives. And Microsoft stores all these disks into a container called storage account. You have to go and create a storage account in order to store those disks that you are creating. There are two major categories. Microsoft provides you managed disk and unmanaged disk. So managed disk is primarily managed by Microsoft, and they provide you the backend reliability aspect or redundancy, and all those stuffs are taken care by Microsoft. But then unmanaged, it is actually managed by customer. So there is a lot of caveats or disadvantages when you go for unmanaged. So preference would be to go for managed. I'll explain why in the next slide. But for now, when you go and store your OS disk or data disk, you'll have to get them stored in a particular storage account. Okay, so and there is one more category of disk that you will predominantly see in most of the Azure virtual machine is the temporary disk. Okay, so temporary disk is something which you get from the hardware where your virtual machines are running on. So in data center, all your virtual machines are running on a physical server, right? That physical server will have local disk with unused capacity. So those capacity Microsoft is giving you for free, and these are all called ephemeral disk or temporary disk, where the data will not be persistent. So when I say data will not be persistent, if you're doing a normal reboot or a routine maintenance, then you won't your data won't get impacted. When you are doing a redeployment of your VM to another host, or if you are taking your VM for a long duration downtime, then that is when your data will be impacted in the temporary disk. So, but then your OS disk, data disk are getting stored in the shared storage out in an external SAN storage. So the data will be always persistent here. So the temporary disk that I'm referring to is mainly on the local disk, which you use for storing your caching contents or page file related contents, virtual memory related data. So the data that you store in the temporary disk is not persistent. Okay. So, but then there are use cases like you can use it for temp database, or you can use it for caching page file. This particular disk is generally like double the size of your memory that you provision. For example, if you provision 12 GB of memory, you'll get 24 GB of temporary disk, and you can definitely configure your virtual memory, the page file on this temporary disk. Okay, but don't store anything that is critical to the business, that is important to the business. So this temporary disk can bring in a lot of performance value, because it provides you caching, and it can store a lot of cached contents, which will improve the application and database performance. So in general, Microsoft currently stores all your data in virtual hard disk format. This is similar to your VMDK in VMware. So you have the VHD, but in on-premises, there are two different categories like VHD and VHDX actually, which is a latest format. But Microsoft Azure, it's still most of the virtual machines, they are stored in the VHD format, virtual hard disk format in the cloud platform. So coming to virtual machine architecture. So as I told you, there are primarily you will have C drive, and then the data drives, which can be as many as you want, and you have the D drive, which is always assigned to temporary disk. Sometimes some customers have a standard of having the D drive for data disk. You can swap it. Okay, you can change the drive later, you can change it, and you have to be carefully handling it, but there is an option you can go and change it to meet the customer requirement. So, okay, so generally all your OS disk and the data disk, it gets stored in a container called binary large object blob storage. I mean, all these disk categories are coming under binary large object. It's an object storage category, and it gets stored as a blob storage in your storage account. If you need any additional shared volumes or shared storage or shared file system, then you can go and create an SMB share on your Azure files, and you can have a drive later assigned to the mapped network drive. Okay, so this is the general storage architecture. You have multiple disks provisioned to your operating system or VM for meeting up the different business requirement. Next is your data disk. So there are two options you get, managed and unmanaged, as I explained earlier. So unmanaged, there are chances that all your virtual machine which are used for high availability, for example, if you're creating multiple VMs in an availability set, you are creating it to avoid any single point of failure. But then if you are using unmanaged disk on the back end, sometimes there are chances both your virtual machine disks might end up in the same storage unit. If this particular storage unit goes down, then both the virtual machines will be impacted. So to avoid such cases, you have to use managed disk, where Microsoft will manage the availability of, or they will take care of storing the virtual machine disks in different physical storage unit, so that if one physical storage unit goes down, it will impact only one virtual machine in your availability set, in your highly available configuration. Similarly, there are other benefits like you can grow up to 10,000 disks per subscription, and manage this gives you a much better performance, and they have the latest what do you call the latest performance attributes configured. It gives you the best IOPS and throughput. Okay, and also it gives you the option to go and configure granular access on your disks when you're going for managed disk. Okay, so managed disk, it is simple. It abstracts the storage account from the customers, and it gives you a lot of performance and scalability benefit, including the security aspect on the access control. So preference would be you have to go and choose managed disk. Unmanaged disk is getting outdated, and it might be removed anytime. So you have to go for managed disk. And within managed disk, or within the disk category, you will have and you will be asked to choose the right disk for the business application or the customer workload. So primary considerations will be around these three areas: latency, IOPS, and throughput. Definitely capacity and security requirements will come into place, but these are the three essential things which you need to consider when you go and choose the disk type. Okay, so there are four categories. One of them is the HDD hard disk drive category, which is the traditional plater spindle kind of the old magnetic disk. And you have the solid state drives, which are the flash drives. And there is one more version within SSD, premium SSD. There are two versions. The version 1 is there, and version 2 is in beta release now. So you can choose the premium SSD version 2 also. So if you start with making a decision here, if your workload is actually input output plus IOPS and throughput intensive, if it is yes, you should definitely go for bare minimum premium SSD or ultra SSD. And if you are looking for sub millisecond latency, which means very high performance requirement, then you need to go for ultra disk, which is the fastest and most flexible disk that is available in terms of cost and performance. And if you are looking for just very high IOPS and bandwidth, and if you're looking for cost and performance balance, you can go for premium SSD, which will be cheaper compared to your ultra disk. But then if your application is demanding consistent performance and low latency, definitely you can go for standard SSD, which is much cheaper, and also it is the entry level SSD option, and you won't feel a lot of issues, but then you'll get low latency and consistent performance, but not that amount of sub millisecond or very high IOPS will not be available. If you're looking for very demanding workloads like your RDS, or for your relational database systems, or for any of your highly IO intensive application, then you might have to go and choose premium SSD or ultra SSD. So standard HDD is very common for your OS drives, and for taking any backup and all those use cases, you can go for standard HDD. Okay, so disk size depends on the capacity that you choose. Based on the capacity, the IOPS and the throughput supportability will enhance or increase. We'll look into that closely. Okay, so we have 5 different disk types, out of which 4 of them are coming under the flash category, solid state drives, and one is on the hard disk drive, HDD. Okay, now, so you can go and choose the disk type based on the scenario or based on the workload requirement. For example, if you are looking for some lightweight web servers or application or development and test environment, then you can start with standard SSD. If it is production environment, production workload, then you need to start with bare minimum premium SSD. Okay, but if your workload is consistent and if it requires very low latency and high IOPS and throughput, then go for SSD. For example, if you're looking for SQL Server or Oracle or NoSQL, not only SQL, MariaDB, SAP, Cassandra, MongoDB, big data analytics, gaming, for all these things, you will need a consistent sub-millisecond latency, and you will need low cost performance balance and all those stuff. So go for premium SSD version 2. This will support even 64 terabyte or terabyte capacity, and it also provides you a lot of throughput, 300 Mbps more compared to your premium SSD version 1, and it gives you 80,000 IOPS compared to the 20,000 IOPS in premium SSD version 1. So it is very it provides you a lot of performance with a balance on the cost aspect. But if you are looking for very high IO sensitive or intensive workload, like your SAP HANA databases or your Oracle workloads or transaction heavy workload, then you can go and choose the Ultra Disk, which gives you 1,60,000 IOPS, the input output per second, plus maximum throughput you can achieve is 4,000 Mbps. But it is based on the size that you allocate. Again, the IOPS and throughput will vary based on the disk size that you are going to choose. So you can only create Ultra Disk as an empty disk. You cannot create it from a snapshot, or you cannot create it from an existing disk. It is more, it is like you can be creating it only as an empty disk, whereas you have option to create these kind of standard SSD or premium SSD from a snapshot, or from an existing disk. You can clone it and get it created. So there are different workloads, and if you want to have a closer look, you can also see that which ones can be used as OS disk. Definitely the premium SSD version 2 and Ultra disk, they cannot be provisioned as OS disk. This is only used for the data and the applications, whereas the premium SSD, standard SSD, standard HDD, they can be used for OS disk. And even if you want to store some non-critical or infrequently accessed data, or if you want to store some backup information, then backup related data can be stored in standard HDD at a very cheaper price. Okay, so now coming to the other aspect. Okay, so we already discussed about the sizing, and we already discussed about the IOPS and the throughput. Okay, so now there are two different challenges that you will face when you go with choosing the disk sizing. Okay, sometimes you will go and choose an instance type that will be capped with a particular IOPS and bandwidth, and your application might be demanding a lot of IOPS or a lot of performance. See, for example, here the bandwidth that the virtual machine that can provide is 1152 Mbps. But then if you are looking out for 1825 Mbps request, then it will try and request the disk. Disk can respond with the capacity, but then when it comes to the machine, it will support only this much bandwidth. So the response will be limited to that, and there will be some performance issues. So when you go and choose the disk and the VM, you need to understand and make sure that you can achieve the maximum bandwidth for your application. Sometimes the workload, the instance size that you choose might be capped with a particular IOPS and bandwidth. So you need to look into that closely. Similarly, so there are chances you will choose the right instance type, but the disk IO will be capped. For example, you will see that there will be only a 200 Mbps for P30 category of disk, whereas when you go for the higher category like P80, you will get 900 Mbps. So you have to choose the data disk smartly in such a way you are not limited to the IOPS or limited to the capacity, bandwidth capacity at the disk level. Okay, so you have to look into both of them. Okay, both the virtual machine IOPS bandwidth limitation plus the disk. Actually, sometimes you will end up getting into performance related issues like that. So how do we identify it? So there are beautiful metrics that are provided by Azure. The basic native Azure Monitor provides you a lot of metrics which you can go and look at each of the disk, OS disk, data disk, and you can find out the IOPS consumed percentage bandwidth for each of your disk category. And you can also go and find out how much each of the LUN is being utilizing. And there is also virtual machine level IO utilization metrics that are coming up, and it is already available in beta, but then so this will be available for general release very shortly. So this will give you an idea how much IOPS is being demanded by your workload, so that you can go and find out whether it is the instance type or the disk type which is limiting your application achieving the maximum bandwidth. Okay, so you also have to keep this in mind when you go and choose the disk. You have to find out whether your disk is supporting the bursting option. Some of the premium disk and some of the disk will support the bursting option. When you go and choose the disk with bursting option, it can help you to pump up your throughput up to a particular limit. Okay, so you can find out whether there is a burst IOP support, burst throughput support, so that you can go and choose a specific disk level type which supports it and which is enabled by default. Even on the VM level, you need to find out whether there is an option to go and burst your throughput, so that you don't end up choosing something which does not support uh, bursting. See, not all your workload needs bursting support, but if you have a workload which has got spiky demand, or if you have sudden spike in the workload, for those, if you want to have better tolerance, if you want to optimize the performance, then go for the VM instance type and the disk type, which supports bursting at both throughput and the IOPS. Okay, now you can see that there are a lot of instance families that support VM level bursting, like DSV series and ESV3 series and LSV2 series. There are a few more as well. So you can go and choose the disk types and the VM types, instance types that support the bursting option. Okay, also when you go and choose the higher category disks especially, so you will not think on the cons, or you will not think on the limitations around those highly performing disk categories. For example, premium version, premium SSD version 2 and ultra disk, they have a lot of limitation. As we discussed some time back, it cannot be used as an OS disk, and it can only be attached to a zonal VM, and it can't be attached to VM in a VMSS, the auto scaling, the virtual machine scale sets cannot have a premium SSD version 2, and also snapshots also cannot be taken. It's the same here also. You cannot take snapshot, you cannot export it, you cannot change the disk type, you cannot take a VM image, it cannot be mapped to dedicated host, and also it cannot have disk level encryption configured. Even the Azure backup and site recovery is not supported for premium SSD as on date. Okay, it's like not currently it is not supported. It might be supported anytime, and you need to keep all these things in mind, and you need to capture all these things in your design documentation so that it doesn't surprise the operations team or the customer that it doesn't support snapshot options, or it doesn't support the backup configurations and so on. And one more important thing, when you go for ultra disk especially, the basic or the default the sector size it supports is 4K. And for example, if you're choosing a particular application like Oracle database, the releases 12.2 and the later version, it can support 4K native disk. But then if you are going with the older version, it will not support that much sector size. So you need to keep this in mind as well, but not I mean, you have to have this in mind, because like not all the applications have such limitation, but some of these highly performing relational databases, we are choosing ultra disk in order to achieve performance. But if there is a limitation on the application itself, then you need to highlight upfront, and instead of finding out later. Okay. So next one is around the redundancy. So sometimes you might want to achieve very high SLA and availability. So if you want to achieve that, Microsoft provides you two redundancy option: local redundant storage. So there will be 3 copies that are getting stored in the same data center within the physical data center, and into 3 different physical storages. And the zone redundancy will have 3 copies stored in 3 physical data centers, 3 physical availability zone. Okay, so there is a zonal level redundancy and LRS option. So LRS and ZRS are available, and write latency for LRS is always better, because all the 3 writes are destined to the same data center. I mean, the 3 storages are in the same data center, so it will be much faster. But then it's not very slow in ZRS, but comparatively write latency will be better in LRS. And LRS just synchronously write data to the 3 copies in the same data centers. It is much faster. And ZRS, in fact, they have ZRS disk lets you recover from failures in availability zone. If there is a failure in one of the data center, your data still is made available from the other data center, because you have 3 copies stored in 3 different physical data centers. And even if you are planning to configure failover clustering, or SAP ASES, or clustering concept, or GFS version 2 distributed application, then definitely you can go and use the shared disk that is provided out of the ZRS option. So ZRS shared disks are giving you improved availability with the clustering features. You can also choose this option. Okay, so shared ZRS disk, you can attach it to 2 virtual machines running in 2 different physical availability zones or physical data centers. So you can achieve much better availability with shared ZRS disks. Next one, you need to consider on the billing aspect. Okay, cost is definitely one of the factor when you go and choose the disk type. So when you go and create a new disk, you need to consider that there is a difference in terms of cost when you go and choose different disk type like premium, ultra, and standard. And even when you go for managed disk, it is slightly costlier compared to the unmanaged one. And you also have to pay separately for the snapshot because it is occupying the size on your storage account. And whatever data you are transferring outside of a data center, outside of outbound data transfers, it is chargeable, and number of transactions are also chargeable based on the IOPS that you are consuming. So next one, there are many different flavors. Right now you can see that there are five different disk categories, and for your application you might also have to do a POC or proof of value or proof of concept to understand what you can achieve, or you can simulate and understand whether your application can get the amount of performance in terms of the queue depth or the thread it needs to perform better. Okay, so generally, like, we use these two tools for Windows and Linux. For Windows, it is Disk SPD, and for Linux, we use the FIO tool. And this can be installed on your development or test machine to go and run this command to identify how much queue depth or what kind of performance you can get from your disk that you have allocated. So, okay, you can get the output of the IOPS and the bandwidth that you're getting. So the benchmarking can be done to down select the specific um, category of disk that is suitable for your application workload. So benchmarking, billing, redundancy, the optimization, the bursting option, and then the capping option, plus the different type of disk. So all these things play a major role in choosing the disk. Not just this, even as I told you, you always should go for managed disk, and also you should choose the SSD in the new deployments as much as possible. Okay, this is what I thought of sharing. Thank you for listening. Thank you.